Okay, this is an Extension 1 topic within Applications of Calculus to the Physical World. It's exercise 6.2 from your textbook, and it's called Rates Involving Two or More Variables. So you've been doing rates involving, I think, just one variable in the 2-unit course. In the extension bit of the course, we do rates involving two or more variables. Okay, just going to start with an example. So, for example, when a balloon is inflating, both its radius and volume, and I suppose you could say its surface area as well, increase, but don't put surface area. So, when a balloon is inflating, both its radius and volume increase. Therefore, I don't know if this is actually related to that, but if we look at, actually let's just start a little new sentence. If we look at the rate of, the idea of this is as follows. If we look at the rate of change of y with respect to x, with respect to time, we are going to use the following result. Volume at the moment. But let's say, if I'm looking at the rate of change of something with respect to time, we can use the following result, which is the chain rule, as follows. If I want the rate of change of y with respect to t, I can do it as follows. Let's say I can't work out dy dt directly. Let's say I've got y in terms of x, and I've got x in terms of t or something like that. We're going to use the result like this. Now, this is not going to make any sense to you until we do some examples. We're going to use this following result, that dy dt equals dy dx times. Now, how am I going to get this to equal dy dt? Yeah, times dx dt. So we're going to be doing things like this in this exercise. Okay, so in the 2-unit part, we were able to, for example, work out dy dt straight off. But I may not have y in terms of t to be able to do it. To do dy dt, y has to be in terms of t. But I may not have an equation of y in terms of t. I may have y in terms of x, and I may have x in terms of t or something. Okay? All right. I think the best way to do this particular, so here we're using the chain rule. The best way to demonstrate the concepts in this exercise is to actually do some examples. All right? So, yeah. Once I do some examples, you'll understand what I'm talking about. I'm going to practice using this result before we do any types of questions. Let's look at, say, question 1 over here. It says find, we can do 1, I don't mind which one, 1C. Let's try question 1C. So question 1C says to find dy dt given that y equals x squared minus x minus 2 and dx dt is equal to -3. Okay? We're just going to practice using that, that result, using that chain rule. So, if you look at this question, find dy dt, we can't find dy dt. The only thing we can find is dy dx. Does that make sense? But we know that dy dt is equal to dy dx times dx dt. And they actually gave us what dx dt was. This is just a very simple example. Very simple. dy dx. So y is x. So I'm just going to put it over here. That dy dx is, what's dy dx? I can put it under here. dy dx is 2x minus 1. So therefore, dy dt, do you want this bigger actually? So dy dt is 2x minus 1 times dx dt is -3. So therefore, expanding, you get that dy dt is what? -6x plus 3. All right, that's a very basic. We're going to do question 2D. It's to find dy dt when x equals 4, given that y equals x ln x and dx dt equals 3. Yeah, because that's all you can do at the moment. So dy dx is, how do you do that? How many functions do you have? Product rule. You've got two functions, x and ln x. So what does u equal? What's u dash? What's v? And what's v dash? Thank you, Megan. Okay, so therefore dy dx is formula? VUV or, yeah, with a plus. It's either uv dash plus vu dash or VU dash plus uv dash, either one. I'm used to writing as uv dash plus vu dash. Okay, u times v dash is x times 1 on x plus v times u dash is ln x times 1. So therefore dy dx is 1 plus ln x. So now we're trying to work out dy dt. Yep, we will. So yeah, we can do it now or later, it doesn't matter. So dy dt is what? Dy dx times dx dt, which is what? 1 plus ln x times 3. Now sub x is 4, and you get that dy dt is 3 plus 3 ln 4. What can I do with this 3? So what I did, I multiplied 3 times 1, 3 times ln x. Yeah, it's a power thing. So isn't it 3 plus ln 4 cubed? So it's, I mean, you can just work out. We need it the most simplest way. So 3 plus ln, I wonder if that's not really what we'd call the simplest form. See, ln 4 is ln 2 squared. 6 ln 2 might be the simplest actually. That's not the simplest. So I'm going to write it as 3 ln 2 squared. Sorry. I'm going to write it as 3 ln 2 squared. Do you know why? Because ln 64 is not the simplest form. So what's the simplest form? What do I do with that squared? So it's 3 times 2, it's 6 ln 2. That's simplest form. So it's 3 plus 6 ln 2. I mean, if I wrote 4 cubed is 64, then I'd have to write that that's 2 to the power of 6 and then bring the 6 to the front. So I could have done it a few ways. Look, if I've got 3 ln 4 is ln 4 cubed, which is ln 64, but that happens to be ln 2 to the power of 6, which is 6 ln 2. 6 ln 2 is simpler. 6 ln 2 is the simplest form. You've got to get the smallest number next to the log. So that is simpler than ln 64. Okay, so 6 ln 2 is simplest form. So the answer is 3 plus 6 ln 2. In the solutions, they've got 3 plus 3 ln 4, but this is simpler. This is the simplified solution. Good practice anyway. 10, just practicing differentiating exponentials if you've forgotten. If a equals e to the power of 3t and dt du is 2, evaluate dA du when t is 0. Again, you've got a equals e to the 3t, so you have to find dA dt. That's all you can do. You do have a formula sheet, guys, but do you remember? With the differentiation, you just differentiate as normal, but if there's a function, you times by the derivative. Okay, that's the differentiation rule. The integration rule is where you've got the 1 on a and stuff like that for both trig functions and exponentials. So it's e to the 3t times 3. So it's 3e to the 3t. So therefore, dA du is dA dt times, it, exactly the same, girls, nothing too hard. So it's 3e to the 3t times 2, which is 6e to the 3t, and you can substitute when t is 0. You just get 6e to the 0 is 6. So they're fairly straightforward. Now we'll do some proper questions. Okay? That's just practicing using the chain rule. That's all we've done. One with a log, one with an exponential. I didn't do a trig one. You can do them. Question 11. Notice that you don't have any formulas. You are going to have to know the formulas. I think they actually do supply some now. In mathematics they do. So girls will need to bring in formulas, for example, for volumes of cubes, surface area of cylinders in all of this, etc. Okay, so, okay, it says a cube is expanding so that its side is increasing at the constant rate of 0.12 millimeters per second. So just write the question out. Find the rate of increase in its volume when its side is 150 millimeters. Now, they haven't given you any equations. They haven't given, so you're going to have to work out, what am I talking about? Is it dV dt? Is it dV ds? Is it ds dt, etc., etc.? That's what we've got to work out for this. Now, you can tell, now I'm going to draw a cube. So I've got a cube. Let's just work out everything we know. That's side length. And what else is this question talking about? Find the rate of increase of its volume. So we should write down the formula for the volume of the cube. So volume is side cubed. Now, we need more than this. So a cube is expanding so that its side is increasing at the constant rate of 0.12 millimeters per second. Millimeters per second, what are those units? What's millimeters? Is it distance or side length? And what's per second? Time. So that rate is d what? ds dt. It's the rate of change of the side length with respect to time. How do you know? Look at the units. The units give you the clue. Millimeters is the change in side length because they're saying that its side is increasing at the constant rate of 0.12 millimeters per second. That means that for every second, the side gets bigger by 0.12 millimeters. That's what that rate means. Every 1 second, the side length increases by 0.12 millimeters. So that 0.12 millimeters per second is ds dt is 0.12 millimeters per second. Okay, now it says find the rate of increase in its volume. What are they asking for? dV dt. Rate of increase of volume is dV dt. dV dt, so this is what they're asking you. They're asking you to find, so the difference between this question and the last ones is that they don't give you all these. You've got to work out what they're asking you for. Once you've written these down, they become like the questions that we were just doing. Easy. So, volume is s cubed, ds dt is 0.12. They're asking you to find dV dt when what? When its side is 150 millimeters. Okay. So find dV, rate of increase of volume is rate of increase with respect to time. Just like rate of increase of side length is with respect to time. Okay, so this is what, pretend you just got this now, that V is s cubed, find dV dt when s is 150. We know that ds dt is 0.12. Let's go. This is question 11. So what do we do? dV, actually, what do we do first? dV ds. Yeah. V is s cubed, so dV ds is 3s squared. Now, I'll have to do something with that. So, therefore, girls, do you have the question written down now?
Yeah.
So I can sort of move it out of the way. dv dt equals dv ds times ds dt. Great, the ds's cancel. We know that that's correct. Sorry, I didn't even mention that before. The ds's cancel. That's how you know it's correct. Okay? I think we've done that before on you. So dv ds is 3s squared times ds dt is 0.12. So now we substitute when s is 150, dv dt is 3 times, yeah, all good? You can work out what 3 times 0.12 is. Is it 0.36? S squared. So therefore, when s is 150, dv dt is 0.36 times 150 squared, which is 8,100 units now, please. Rate of change of volume with respect to time. Volume will be millimetres cubed per second. So you either write it as millimetres cubed per second or millimetres cubed second to the minus 1. That's how you write your units. Volumes units are millimetres cubed. Divide by time is divide by seconds because we were told that these units up here were per second. So therefore this is per second. dv dt, volume units, divide by time units. All right? Next question. Okay, the radius of a cylindrical, so we're doing question 12. Write the question out. The radius of a cylindrical pipe that is 2 metres long. So I'm going to do a bit of a diagram. It would really help if you do. Makes things a lot better. So the radius of a cylindrical pipe, 2 metres long, so that's the length of the pipe, expands with heat. We all know that that happens because it's a metal. At a constant rate of 1.2 times 10 to the minus 3 millimetres per second. Now, what is that number? 1.2 times 10 to the minus 3 millimetres per second is d what? D what? The radius, let's just define what we're going to call what. There's my radius. So this is telling me that dr dt, the radius expands. The reason that this is a positive rate as well is because it's expanding. Let's say this was a really hot cylindrical pipe and it was being cooled, then the dr dt would be negative because it would contract, okay? So dr, provided it's already been heated. It's not going to... So dr dt is 1.2 times 10 to the minus 3 millimetres per second. Wait, can't see my thing. Wait, I'll just, radius divided by time. Millimetres divided by seconds. Makes sense. If you're stuck, look at the units. That's how you can tell what it is. You look at the units. Distance divided by time. Okay? It says find the rate at which the volume of the pipe will be increasing when its radius is 19 millimetres squared. So what are they asking you? To find what? dv dt when r is... The question's asking you to find dv dt when r is 19 millimetres. So therefore, well, what do you need? We're missing something. The volume formula is pi r squared h. But guess what? We know, good, which is pi r squared times 2 as h equals 2. So therefore the formula for the volume is 2 pi r squared for this particular pipe. Amazing that it's only expanding widthways and not length. They should consult the physics people before they write these questions. Those little electrons. Okay, so what do we do now? All good? What do we find? dv dr is, yeah, it's 2 times 2. 2 times 2 pi r, oopsie, which is 4 pi r. Remember bringing the 2 to the front? So now you can finish off your question. dv dt is dv d, all good? dv d r. Is the question too big? Gloria's not here, so we can make it small. Tell Gloria she's not here, so we can make the question bigger. Smaller. dv dt is dv dr times dr dt, which is 4 pi r times 9 times, what's dr dt? Times 1.2 times 10 to the minus 3. You may as well just substitute it all in. 4 pi times 19 times 1.2 times 10 to the minus 3.
I got 0.2829.
You should get and we've made a mistake. And what is the mistake? Let's change this now. So it's pi r squared times 2,000. Let's go 2 meters is 2,000 millimeters. So that is 2,000 pi r squared. 2 times 2,000 pi r, which is 4,000 pi r. We should have just times it by 1,000 here. You know, just here. Get rid of this 10 to the minus 3. Thank you. That's what we should have done. Or just change the 19 into meters, but then your answer is meters cubed per second. So we've got 4,000 pi r. So 4,000 pi times 19. This will give us an answer in millimeters cubed per second. 286.5 millimeters cubed per second. So guys, please watch out for that. Difference in units. 2 meters. See, guys, you've got to, you know what? You've got no other option but to change it to millimeters. Why? Why? No? Why? What's the rate given to you as? Wait.
0.287.
That must be.
That's in millimeters.
Oh, it is? Can someone look that up? Do that? Did you do that times that times that? Is that what you got?
Yeah, but that's.
Oh, no. I haven't got a calculator. I'm just calling out.
That's the calculator, but in the answer it says 0.287.
Yeah, that's the thing.
What did we get here?
I think this answer. Yeah, I think that I made a mistake too.
Yeah. Guys, does this look right? This is right. That's it in millimeters. That's definitely correct. 4,000 times pi times 19 times 1.2 times 10 to the minus 3. What do we get? 286?
Yeah, 0.5.
That's it. 286.5. That's what it is. Guys, stop. The textbook's written by a person. So, textbooks written by a person, they could get it wrong too. It's definitely 286.5 millimeters cubed per second. There's other units. If you do decide to keep this as meters, you have to change this rate to meters per second. You have to change, guys, I'm just trying to tell you, if you want to keep this as meters, the rate needs to be changed to 1.2 times 10 to the minus 6 meters per second, and this 19 millimeters needs to be changed to 0.19 meters. So you have to make 2 changes. So girls, instead of changing those 2, just change the meters to the millimeters. Because if you think you've just got to change the 19 millimeters to meters, you're wrong. The rate is in millimeters per second. That would have to be changed as well. You would never make 2 changes, okay? You'd make the 1 change the meters to millimeters. 13, what's the surface area of a balloon? I'm just going to write little notes. Question 13. What's the surface area of a balloon? Surface area of an orange. Do you remember when you did that video? 4 oranges. Surface area is 4 pi r squared, but, well, let's call it S for surface area. What else have you got? Find what? Find what? So what's the question asking you? Find, guys, ds. Find the rate of change of surface area. What's that? D. I've let S equal surface area. Find ds dt when R is, yep. And what other information do you have? D. You're also given that dr dt is 1.3 centimeters per second. I'm not doing the question. You know how to do it. All right? We're just going to discuss a few things. We're going to drop. We're going to move now. But that's what you need to do for those questions. You've got the volume formula? No. What are they asking you? Where H is the liquid. If the height of the liquid is increasing at that rate, what does that mean? D what? D H dt is 2.3. And what are they asking you to find? The rate of increase of the volume. They're asking you to find dV dt when H is good. All right, so we keep going. What's this asking? This is the change in the y coordinate with respect to the x coordinate. A point P moves along the curve. What will be the rate of change in the y coordinate of P? Let's do, well, it must be dy dt. When the x coordinate is increasing at the rate of 8 units per second. It is with respect to time. How do you know? Because the x coordinate is increasing at the rate of 8 units per second. So this is d what? dx dt is 8. Do you see that? dx dt is 8. You substitute x is 3. They want you to find dy dt. All right? Remember this all on video. Ice cube. I think, oh, this one's good. Let's do this. We can talk about this or we can do this, but there's something special with question 16. Yeah, you can write this one, but you can finish it off at home. We're just starting it. Question 16, an ice cube with sides x millimeters is melting so that its sides are decreasing at the rate of 0.8 millimeters per second. So let's draw. The sides are x. Can we have a bit of a diagram?
Are we doing the whole of this question?
Oh, look, we'll just do it all. Yeah. So, an ice cube with sides x millimeters is melting so that its sides are decreasing at that rate. 0.8 millimeters per second. What do I write? D, dx, d, millimeters per second. What's that? dx dt is negative. That's what you've got to do. You don't put 0.8, it's negative 0.8 millimeters per second. Otherwise, your ice is going to get bigger, not smaller. Okay, so this is really important that you put the negative because it's decreasing at that rate. So the rate won't have the negative on it. You've got to put the negative with it. All right, what will be the rate of decrease in volume? So they're asking you for dV dt when x is what? 120. What are we missing? V is x cubed. Go for it. You can do that yourselves. dx is 3x squared. So dV dt is dV dx times dx dt, which is, actually we've got to do the ones with 3 quantities. We haven't got to those yet. Guys, we're nowhere near finished. These are the easy ones. So then we can substitute. So you should get a negative answer. 34,560 millimeters cubed per second. Therefore, you make the conclusion that it's decreasing at the rate of. So decreasing at rate of, then you don't put the negative in. 34,560 millimeters cubed per second. Now, I need to do some of the harder questions. These have only got rates involving 2 variables. We need to do rates involving 3 variables. I'll go to the end of the exercise now. Spherical bubble is increasing at a constant rate of that. What's that? ds. All right, I'm going to let S equals surface area. What's the formula for the surface area of a bubble or a balloon? A circle. Surface area of a sphere. 4 pi r squared. What is the formula for the volume of a 4 on 3 pi r cubed? Wait. What do you think you should do with each of those quantities? Differentiate. ds dr is 8 pi r and dv dr is 4 on 3 times 3 pi r squared, which is, and then we'll see what we're going to do, which is 4 pi r squared. Isn't that amazing? That dv dr is the formula for the surface area. Okay? So that's what dv dr is. So we've got 2 formulas, one for surface area, one for volume. They're saying that the surface area, so ds dt, the surface area is increasing at that constant rate. How do we know? You can see the units. Millimetre squared is an area unit, per second is a time unit. So ds dt is 1.9 millimetres per squared. That tells us it's the surface area over the time. Find the rate of increase of its volume when the radius, so what do they want you to find? Find dv dt when r is 0.6. Now let's see how we're going to find dv dt. dv dt, we're actually going to have 3 things here. dv dt will be dv d what? What is the only thing you can find? dv dr times, guys, I know we've got ds dr, but we can flip it, times dr ds. Watch what I'm doing. I have to put the dr up there to cancel, right? Times, how am I going to cancel the s? ds dt. I've got a double cancelling happening. The dr's cancelled, the ds is cancelled. Got it? So, dv dr is 4 pi r squared. dr ds is the flip of 8 pi r. So what's dr ds? 1 on 8 pi r, and ds dt is 1.9. So we can simplify 4 on 8 and the pi's cancel. Yeah, so we can sub, well, I'm just going to simplify it first. I've got 1.9 over, no, 1.9 r over 2. Because the pi's cancel, the r's, one of the r's cancel. So sub, I'm just going to put sub r is 0.6. And you get that it's 1.9 times 0.6 over 2.
Evangelia Alexakis to the office.
Which is?
And Bridget Paul, please, to the office.
0.57.
Whoa.
And an announcement that the care meeting is now on NPL2.
Yeah, I can't find my answers. Did someone check that? 0 point? Units, volume, millimetres cubed per second. Okay, girls, so they're the 3 ones. Now, all right, I'll have to, what I'll do, when I post the video, I'll select the questions for homework.